Hi, College Algebra. We're going to start lesson 4 or 5 today. I'm going to go through the first half of the notes, and then tomorrow I'll pick up and finish off the second half with another video. So in lesson 4 or 5, we are going to solve exponential and log equations. So today's focus will be solving exponential equations. There's a few rules up here at the beginning that you need to remember. These are one-to-one properties, and we're going to be using them throughout the lesson. So the first one here says basically, oops, hang on just a second, bear with me. There we go. Okay, the first one says that if I have the log base a of x equals the log base a of y, then I can drop the two logs and x would equal y. Likewise, if I start off with x equals y, then I can put the log on each side. So that's the log of x equals the log of y. Or I can do the natural log of x equals the natural log of y. So the point is you can put a log on each side of an equation as long as the log on each side has the same base. Okay, how is that helpful? Well, for example 1, 8 to some power, like 8 to a power doesn't come out to be perfectly 21. 21 is not a multiple of 8, and so x is going to be some decimal value. So I do know that 8 to the first is 8, and I know 8 to the second is 64. So I know that my decimal value is somewhere between 1 and 2, closer to 1 than 2, because 21 is closer to 8 than it is to 64. To get that decimal value fine-tuned, what you're going to do is you're going to take and insert a log or a natural log on each side. And it doesn't matter if you use a log base 10 or the natural log, but you're going to put a logarithm on each side of the problem. All right, by putting the logarithm on both sides, that allows you to take your exponent, this guy right here, and bring it down to the front. So now I have x log 8 equals the log of 21. X equals the log of 21 over the log of 8. And then I'm going to run that into my calculator, and it will be about 1.464. Now another way to do this problem would be to switch it over to logarithmic form first. So method number 2 would say this is log base 8 of 21 equals x. And then some of you guys would see that as change of base from the last lesson. So in 4.4 you learned about change of base. So x would be the log of 21 over the log of 8. Remember, the base goes in the basement. And then if you put that in your calculator, you're right back where we started. Okay, example 2, let me rewrite it for you. We're going to solve 5 to the 2x minus 3 equals 8 to the x plus 1. So for this first half of the lesson, this type of problem right here will be the toughest one that you see. So I'm going to go nice and slow so you guys can kind of watch what I'm doing and pause when you need to. All right. I have an exponent on each side. So what I'm going to do is put my log on each side. All right, and again, the reason why you want to do that is so that you can bring your exponents down to the front. Now, when you do that, your exponents have more than one term. So we're going to be using some parentheses here in a minute to block those off. So the exponents come down in the front. And again, I'm blocking them off in parentheses. Okay, what I want to do is I want to get my x values all together. So what I'm going to have to do now is distribute. So I'm going to take 2x here and -3 there, x here and 1 here. All right, now what we're going to do is we're going to take any term that has x in it, and we're going to put those on one side of the equation. And if it doesn't have x in it, we're going to stick it on the other side. So I'm sorting my terms. If you have x, you're going to the left, and if you don't have x, you're coming to the right. Okay. Each term on the left has an x in it. So what I'm going to do next is I'm going to factor that x out. And then finally, I'm going to divide. And I'm dividing so that I can get this x by itself. All right, now here's my words of caution. You're going to be putting this into your calculator. You have to be super careful how you put it in your calculator. You will more than likely have parentheses here, and that's pretty standard. However, you're also going to need parentheses here and here, here and here. So make sure, and I stress this, make sure you get enough parentheses in there so that you don't struggle with your calculator. The answer should be about 6.062. Practice that with your calculator, get good at it, and we're going to move on. Okay, this third problem is another exponential problem, and we're going to work with it so that we can find our exponent, or find x, which is part of your exponent. Okay, this one needs some cleaning up first. So these two exponents here are going to get added together to begin with. We're going to add those together. So we have e to the 5x minus 1 equals 5 to the e. I have a base on each side. What I'm going to do next is divide this e over to this side. And that's an e to the first. These exponents will get subtracted. So the rules are, when I'm multiplying like bases, like I did at the beginning of the problem, I add my exponents. But when I divide my like bases, I subtract my exponents. And 5x minus 1 is 5x minus 2. Okay, so I've cleaned it up first. Now what you're going to want to do is you're going to want to take the natural log on both sides. So because this is base e, I'm going to do the natural log. Okay, this comes down to the front. It's in parentheses because it's a group. Okay, the other day I asked you to memorize that the ln of e is 1. So that's going to take the place right here. So I have 5x minus 2 times 1 equals the ln of 5. Now I'm just going to solve for x. I'm going to add the 2 to the other side. That does not become the ln of 7. It stays apart like that. Then I'm going to divide by 5. Now, if your textbook asks for an exact answer, this is an exact answer. or we'll say exact value. This is an exact value. If they say they want a decimal answer, then they will tell you how many decimal places to round to. All right. This is the end of the first part of your notes. I might look for another video online to see if there's some more out there that can help you. And if so, I'll post those on Canvas as well. The next video that I create will go over the rest of your notes, which start here with part B, log equations.